Okay, now the first question says define moment of force and state its unit. Also write relation between its SI and CGS unit. So let's see what will be the answer. So the answer is the moment of force or torque is equal to the product of magnitude of force F and the perpendicular distance d of the line of action of force from the axis of rotation. SI unit is Newton meter and the CGS unit is Dyne centimeter, and the relation between SI and CGS unit 1 Newton meter is equal to 10 raised to power of 7 Dyne centimeter. Now second question is why a spanner has a long handle. Why is it easier to open a door by applying the force at the free end of it? The stone of a hand grinder is provided with a handle near the rim. Now answer for all these questions are the same. The torque required to rotate a body about its axis of rotation depends both on magnitude of force, this F, as well as the perpendicular distance from the axis of rotation, that is D. So we can say larger the force, larger the perpendicular distance, less is the force needed to turn the body. So that's why we increase the distance in all these examples. We have increased the distance so that the less force is applied. Okay, the next question says, what do you understand by the term couple? State its effect and give 2 examples of couple action in our daily life. This is the answer. 2 equal and opposite parallel forces not acting along the same line form a couple. A couple is always needed to produce a rotation. So see, state the effect, it always produces a rotation. Then the 2 examples in our daily life, turning a water tap whenever we have to open or close it, and the turning the key in the lock of a in the hole of a lock. Okay, in the next question we have to define moment of couple and then write its SI unit. The moment of couple is equal to the product of either forces and the perpendicular distance between the line of action of both the forces. And that distance between the line of action of both the forces, that is called couple arm. See here you can see the rough sketch. 2 equal opposite parallel forces not having the same line of action. So they are forming a couple. Now the distance between the 2 forces, this is called couple arm. So when you have to calculate the moment of couple, this is not moment of force, this is moment of couple. So that will be equal to either of these 2 forces and the distance between them, that is called the couple arm. Next we have to write its SI unit. So its SI unit will be Newton meter. Okay, the next question we have, state 2 conditions for a body acted upon by several forces to be in equilibrium. So the answer is the resultant of all the forces acting on the body should be equal to 0, and the algebraic sum of moments of all the forces acting on the body about the point of rotation should be 0. So these are the 2 conditions. The next question is state the principle of moments and give 1 device as application of it. The answer is, according to the principle of moments in equilibrium, sum of anticlockwise moment is equal to sum of clockwise moment. And now the one device, a physical balance, or you can take a beam balance, it works on the principle of moments. On what factors does the position of center of gravity of a body depends? And we have to explain this with an example. Okay, the position of center of gravity of a body of given mass depends on its shape. The changes it changes if body is deformed. The center of gravity of a uniform wire is at its midpoint. But if this wire is bent into the form of a circle, its center of gravity will be at the center of circle. See, if you consider a wire, its center of gravity will be at the midpoint of the wire. It can be like this. See, we consider a wire, center of gravity will be at the midpoint of the wire. But if this wire is given a shape of a circle, then the center of gravity will be at the center. So that means the center of gravity changes its position if the body is deformed. The next question we have, can center of gravity be situated outside the material of the body? Well, answer to this question is, it is not necessary that the center of gravity always be within the material of the body. You can take the example case of a ring. In ring, the center of gravity, or you can take an example of hollow sphere. There also the center of gravity lies at its center where there is no material. So that means center of gravity can lie outside the material. The next question, give an example of motion in which speed remains constant but velocity changes. Answer is uniform circular motion. Okay, next is name the force required for circular motion and state its direction. Answer is, it is the centripetal force, and this force is always directed radially towards the center of the circle at each point of its path. Next question is uniform circular motion an accelerated motion? Now remember, in uniform circular motion, the velocity of a body always changes, because body is moving on a circular path, so direction is continuously changing. So we can say that velocity is variable, and if velocity is variable, then we can say that it is an accelerated motion. So uniform circular motion is an accelerated motion. And why? Because velocity is variable. Okay, next we have to differentiate between a uniform linear motion and a uniform circular motion. The uniform linear motion is an unaccelerated motion. There is no change in velocity taking place in uniform linear motion. While in uniform circular motion, velocity is variable, so we can say it is an accelerated motion. Now we have to give one similarity and one difference between centripetal force and centrifugal force. Now, both forces are equal in magnitude, but the direction of centripetal force is towards the center, that is inwards, while centrifugal force is radially outwards. That's the difference between them. Then we have the next question, at which point is the center of gravity situated for a triangular lamina, for a rectangular lamina, and for a circular disc? For a triangular lamina, at the point of intersection of its median. For a rectangular lamina, at the point of intersection of its diagonals. For a circular disc, at the geometric center. So these were the few important questions from this chapter.